In this example, we're going to talk about some potential problems with Newton's method. Newton's method, just a quick refresher, is to help us figure out where x-intercepts are. So in this particular problem, we were looking at where they intersected each other. So we set them equal to each other, and then we brought everything over so it was equal to 0. And that's what Newton's method is really good at, is it's finding out where these graphs where the x-intercept is of this graph. And so formula for that is we're going to do a couple different iterations, and it's going to be the x value minus the y value divided by the slope. And then we just keep on running it a couple different times, and then eventually we get ourselves a very, very good x-intercept, a good solution to this. So there are a couple problems. One is if you have a problem like this, we want to make sure that the denominator at no point equals 0. Also, a problem is that this thing starts to converge down to a point, but maybe it takes too long for it to converge or doesn't converge at all. All right, so here's a couple different situations. So we have this equation. This is the slope of that equation, and I'm going to let the calculator kind of help us work through this. So first thing is I got to get this thing going. And so to get this thing going is I'm going to start with a value. And we're starting with a 1, and then a 0.15, and then a 1.1. And so these are 3 different situations and see what happens. So we'll start by storing our value. So we're going to store, remember the store value is down here. So, sorry, I need to take the number 1 and store it as an x value. Perfect. And then I'm going to go ahead and create Newton's method. So I'm going to do x minus our y1. Oops. Let's make a fraction. Our y1 at our x value divided by our y2. And I'll show you what these equations are here in just a second. And then I'm going to press enter and let it do its thing. And so what I did was our y1, I took our original equation and I went ahead and input it as my y1. And then my y2, I input the derivative of it. And so I'm basically creating that, right? Letting the calculator do the math. Okay, so that's where we're at. And so I plugged it in, I let it do its thing, and we got our first iteration at -1. Perfect. So then I'm going to store that value. So I'm going to store that answer. So I just press store as x and let it do its thing. And I get a 1. Okay, so I will store that as x and let it do its thing. And I get a -1. So clearly we are into this kind of a loop. It's going to just go on and on and on and on and on. So it does not converge. So it does not converge into one nice value. It just kind of goes through this infinite circle. So there's one issue. And then if we do store 0.5, so I'm going to do the exact same process. And I'm going to take 0.15 and store it as x. And let it do its thing. I get this value. So switch this. I get our first iteration at 0.0699375. Let's do it again. So we'll store that as x. And then we'll let it do its thing. So 0.034455669. And then we'll store that as x. Let it do its thing. 0.01716645554. Store that as x. Let it do its thing. All right. So 0.008575639. So if I do this a couple more times, I'm not going to write them all down anymore. I'm going to store that as x, let it do its thing. And then I'm going to store it as x. Let it do its thing. So I'm really not getting to a value very quickly at all. And so this thing just kind of keeps going and going and going and going versus any other time we've done it. It kind of converged pretty quick. Like we went to that fifth iteration, it was the exact same value. We went to the fifth iteration, it was the exact same value. So we went to the fifth iteration and it was not even close to the exact same value. Nothing has locked except for first couple of zeros. And so it's taking too long. There are more efficient ways to do it. Where Newton's method works pretty well a lot of the time, but sometimes it's not amazing. And then we'll do one more at the 1.1. So same stuff. So we'll start this over. We're going to take and store 1.1. We're going to store it as x and then start our Newton's method again. And so our first iteration is a negative 1.4465. We'll store that as x. Let it do its thing. So x2 equals 3.816652992. And then we'll store that as x. This thing, we went negative 81.4865340.6. Do one more. So we'll store that as x. Let it do its thing. Okay, so that went bad, really bad. So now we're at 811,571.887. So this thing just blew up, right? So if we do it one more time, we'll store it as x, let it do its thing. We went to something that was absolutely huge, right? Scientific notation, we'd be shifting this thing 17 decimal places. So this thing went to, I have no idea, right? So sometimes it doesn't work. Sometimes it doesn't converge, it just gets us into some sort of an infinite loop. Sometimes it's just taking forever. How many of these do I really want to do? Maybe there's a better way, there's better methods to this. And then sometimes who just knows where it goes. So that was an absolutely bad value to start with. So there are some pitfalls to Newton's method. A lot of times it works amazing, but there are some times that it just doesn't work.